Hi everybody, Denny here from ColdQuanta. Welcome to 3 Minutes of Quantum Computing. Today I'm going to start developing the QUBO which captures the StarBattle puzzle that I introduced last week. You'll remember that each region of a StarBattle puzzle must have a fixed number of stars. In the case of an 8 by 8 puzzle, that number is 1. I neglected to mention that each column and each row must also have 1 star. These three rules are all examples of the k of n constraint. These are posed over n variables and require that k of the variables are equal to 1 and the rest are 0. These occur frequently in converting problems to QUBOs. In an 8 by 8 StarBattle puzzle, the row and column constraints are 1 of 8. Because we need to make sure that exactly 1 of the 8 variables living in the row or column are turned on. Since the regions may have different sizes, we can think of those rules as 1 of n. Here is a constraint for the first row. The subscripts on x are the row and column of the cell associated with x. Let's rewrite that using a summation and enumerate its possible values in a table. When the summation is equal to 1, the constraint is satisfied, and otherwise it is violated. Now, notice what happens if we subtract 1 from the summation and then square the result. Subtracting 1 means that the possible values range from -1 up through 7, with 0 corresponding to the constraint being satisfied. Squaring this quantity converts all non-zero values into positive ones and leaves 0 unchanged. The result is that this function achieves its minima if and only if the constraint is satisfied. So, the expression at the top of the rightmost column is exactly the QUBO which results from the 1 of 8 constraint. Now we need to replicate this work for not just the first column, but for all columns, and all rows, and all regions. Each row, column, and region gives rise to another QUBO. We can write the form of the QUBOs for the rows and columns directly because the subscripts encode the row and column location for each variable. To write the QUBO for each region, I've used capital R sub I to indicate the set of row-column pairs comprising region I. You may be wondering about how we combine individual QUBOs for the column, row, and region constraints. After creating the individual QUBOs, we can simply add them together to obtain the global QUBO. Following this approach, here is the summation of all the sub-QUBOs that we have created so far. In the case of the 8 by 8 StarBattle puzzle, there are 8 region constraints, 8 column constraints, and 8 row constraints. So we have decomposed the global problem into 24 constraints so far. But what about the neighbor constraints? They must be included so that our QUBO accurately represents the puzzle, but we haven't done that yet. Those are not n of k constraints, so we need a new idea. Next week I'll introduce another technique which we can use for the neighbor constraints. That's it for today. Thanks for watching. Bye everybody.